Okay, so recording has started. Welcome to the March 21 edition of the study hall, whose theme is flexibility in problem solving, part 2, where flexibility in problem solving part 1 was almost exactly a year ago. It was somewhere in March or April of last year. So finally, part 2 of this, where flexibility in problem solving means, someone's got a Gonzaga fan out there. Flexibility in problem solving means, approaching things in as many different ways as you possibly can. So a note about the source of these problems. These are from GMAT Prep unless we say they're not from GMAT Prep. Also, when you do these, what you're going to see, you should see them starting right now. You should see lettered multiple choice options. You should see A, B, C, D, E. They should just have appeared underneath your name. So this is where you pick answers to multiple choice questions. If you've been doing these study halls for a while, you will know this, but there's always new people. So that's where you make multiple choice selections. Please don't put your multiple choice answers in the text box, because remember, we don't want everybody seeing the same thing and having clues that they don't really want. So if you put your answer here, no one sees each other's answers, because I've got that hidden. And remember finally how this test works. This is not a test where you can not answer things. This is a test where you have to answer all the items on the test in the order you get them. There's no revisiting problems. There's no skipping problems. There's no going back later and changing your answers. There's no any of that. You have to answer the questions in a way that is final, right when they come out. So, smiley face, if this makes sense. Remember where the smiley faces are. Okay, someone gave me the LOL. There's some smiley faces. All right, cool. Okay, let's do it. So here's a problem. How about that? And remember where you're going to find the answers to multiple choice questions. You're going to find them here, where it indicates on the following graphic. Right here. All right, here's a timer. This one's got words and pictures, so we might need to allow more time for this one. So I'll give you, up to almost 3 minutes here. Enjoy. Okay, ladies and gentlemen, it has been almost 3 minutes. In fact, it's been 3 minutes. So you should be punting at this point, if not before. So there's like 35 people here, and so far we only have about 12 answers to the problem. So that means that a lot of you have some guessing to do at this point. So just guess away. And then we're going to have some learning to do about strategy. Okay, so again, we still have about 10 non-responders. So if you have to guess, just get into the habit, right? Get into the habit of putting a guess down for this problem. But don't hang on to it for too long. By the way, a reminder for those of you who are late to the session, in this basketball tournament, these are the good guys. The good guys. The Louisville Cardinals. The Florida Gators are also the good guys. I don't know if that'll help you on the GMAT, but it'll help you in life to know who the good guys and the bad guys are. Okay, back to the problem. So let's take a look at it. So when it's a word problem, I mean, it's more of a geometry thing, but it is a problem that has words in it, so hence a word problem. So, I mean, we've had some other study hall themes on word problems before, but the idea with word problems is that you should read through all the words first before you do any math, and you should make sure you understand what the heck the situation even is in the first place. So remember that you should read them twice. First read, and there's whole sessions on this. I mean, there's a study hall session called like Organization in Word Problems or something where you can read all about this. The first read, you should basically ignore math or numbers and don't try to write equations. And instead, what you're doing is you just understand the situation, which is like, what are the quantities? What's happening in the situation? What quantities are there, or what things, what items or mathematical quantities are there? How do they interact? Etc. Make sure you understand all of this first. And then you want to organize in some way, which in many word problems, that means making some kind of chart or a thing like that. I mean, here a chart is probably not a very sensible thing to make because it's like a visualizing problem. But you might want to draw it, or you might not. But some sort of organization. I mean, this could mean anything from just getting things straight in your head all the way to like actually making a physical chart on a piece of paper. It could be any of those things. So be aware. Okay. Can anybody think of, so remember what the theme of today is, besides the good guys. The theme of today is flexibility in problem solving. So remember what that means. That means, that was just a cheap excuse to put that cardinal up there, I guess. But flexibility in problem solving is many, many ways to solve problems, including ways that are not textbook methods, right? So can anybody think of a way to solve this problem that is not algebra? If you can, then type it in the text box. Because this problem is not so bad if, oh, here's your class results, by the way. There's still 6 non-responders, which is not really what we want. So, but yeah, you can pick numbers. How about that, right? One of the most key strategies that you've got, Rajiv says. Rajiv, tell me more about pick numbers. Tell me a story about that. If you, don't type a million words, but just give me the brief summary of what you mean when you say pick numbers. Let's see, is Rajiv, are you typing? Yeah, you just take the answer choices and put you just make up your own value for something and just throw it in there. So it is true that at least 6 of, Steven says at least 6 sides are covered in red, but let's chase this particular rabbit right here and see how far we can get. So let's pick a relatively easy number. What can we pick for n here? Like, we don't really want an n that's like 15, because then you sort of have a problem of the same level of complexity as it used to be. How about 2? Hey, how about that? Because, I mean, you can't pick 1 because that's not an allowed value in the problem. But notice the condition that's up here. But the simplest case that we can pick is n equals 2. So just go ahead and do that. Pick your own numbers. Simple cases. So let's just go ahead and let's just set n to be 2. So then you kind of know what you can sketch this if you feel like you have to sketch it. You may or may not feel like that's something you have to draw, but if you draw it, it's a cube that's 2 by 2. So when it's broken up, it's going to be broken up into 8 different cubes, right? So you've got, it's going to be subdivided like that, and like across here. I mean, this is not the greatest drawing in the world, but I think we get the point, right? So we have a 2 by 2 by 2 cube. There are 8 cubes total here. How many of them are painted? I mean, all of them are, right? If you look at this, like all of these things are actually painted on 3 sides. Like they're not just all painted. They're actually all painted on half of all of their sides. I mean, every single cube in this arrangement has 3 faces outwardly facing. So the answer is definitely 8. I mean, all of them have lots of paint on them. So all of these have lots of paint on them, all the paint, everywhere. So the answer is 8. So then what do you do? Well, remember that n is not n anymore. I mean, you don't expect a choice that says 8, because if n is not 2, then the answer is not 8. So you have to just take the same. This is just the situation where n is 2. So you take that and you throw it in there, and you get what you get. So choice A is 6 times 2 squared, which is not 8. B is 6n squared is still 24. 24 minus 12 times 2 plus 8, which is 8. Okay, are we done at this point? Chat box, tell me. Yes, no. I mean, 8 is the number we want, right? Okay, so most people are saying no, we are not done, but there are still people who are saying yes. So yeah, there could be more than one 8, right? Let's make sure we talk about why this is the case. This is really important. Like, pick your own numbers is one of the most powerful methods that you've got. It's one, I mean, for bypassing difficult or annoying algebra. I mean, it's one of the most potent methods you've got. But you have to be careful. And I mean, it's best to use a simple, like let's use a kind of simple and easy to understand problem as an illustration of this. Like let's say you have the following problem. What is x plus x? I mean, okay, that's not hard for anybody. Choice A, it's x squared. Choice B, it's 2x. Okay, so the answer to this is definitely B. But do you guys see what happens if you are unlucky enough to plug in 2 for x? What happens if you do that? Chat box. You plug in 2. You get the same answer for both, and worse, the wrong answer is listed first. So if you just picked the one that you saw, oh, look, I got a 4. So 2 plus 2 is 4. That's the answer that I want. So if I just say, oh, A is 4, if I pick that, then I'm actually going to get the whole problem wrong. So you got to be very careful there. But B is also 4. So this is unfortunate, but it's not a big deal because all it means is that you just throw another number in there and don't worry too hard about it. So if you plug like any other x that's not 2 or 0, like I don't know, 5. So then you want 5 plus 5 is 10. And A is not 10 anymore. It's 25. And B is 10. So this is the worst that can happen, but you do have to keep going when you get your 8, especially because you have picked the simplest possible case. Like if you did, honestly speaking here, if you did this, not that this would be a good idea, but if you plugged in like 17 for n, and you actually solved this problem with 17 cubes on the side, then you would definitely not get any answers the same, and you could just quit when you saw it. But if you do pick the simplest possible case, you don't really know unless you plug. So just keep going, just keep trucking through the choices. So it should be an unbroken process. C is 24 minus 16 times 2 plus 24. So that's not 6, that's 16, that's not 8. D is 4 times 4 is 16 again, which is not 8. And E is 48 minus 24, which is not 8. Oh, look, we're done. Legit. I mean, if you don't like the idea of 2 for n, then you can pick 3. In the case of 3, you have all the cubes painted except for the one that's right in the middle. So this is fantastic. And I mean, again, most people didn't get this problem right. I mean, out of 30-odd people in here, I think we had 11 correct answers. So that's not a very good hit rate. So if you were one of the individuals who got this wrong, or even if you guessed, even if you got it right, if you had to guess, that's still a thing. If you had to guess or if you missed the problem, this is a big wake-up call. I mean, this is not a hard problem if you pick numbers. But if the only tool in your toolbox is algebra, then you're going to be in big trouble on this one. Any questions about the picking numbers method? If you have questions, feel free to fire away in the chat box. Okay. All right, no one is asking questions. I don't know if anybody is typing anything, but yeah, I mean, we're going to get there, right? But Linda, when you ask that question, I mean, of course, that's a legitimate question, but make sure that you are not asking that because you are dismissing this solution. I mean, it's hard to really say, but usually people are like, oh, I don't think I care about plugging numbers. Let's just jump to the algebra. So just make sure that that's not what's happening. As long as that's not what's happening, then great. And I mean, especially, we'll get there in a sec, but let me tell you something here, which is that if you are, because a lot of people who attend this study hall have, Maria, the number of small cubes is 2 times 2 times 2, length times width times height. So it's 8 in this instance. And they all have paint. If you guys, I don't get how dividing by 2 is 8. Penn, Glenn, I don't understand. Maybe you're not reading the problem right. It's not how many faces of the cubes. It's not how many squares. It's how many of the blocks have paint on at least one face. It's not the number of faces. So what does N stand for? Well, so okay, this kind of question, what does N stand for, is exactly the kind of thing I'm talking about when I say first read of the problem. Like if you are trying to do math here and you don't understand stuff like that, you're going to be in big trouble. Just try to understand the situation, what's going on. I mean, if 100% of your attention is going toward let me understand the situation, then you will figure this out. Like you have a big cube that you slice up into n cubed smaller cubes that are each the same size. So what that means is your n is like how many cubes on a side. Like if n is 2, it means you're cutting it up so there's 2 cubes this way, 2 cubes that way, and 2 cubes that way, and so on. Because that's, I mean, you might have to think about that for a little bit, but make sure you do think about it for a little bit if you have to. So there's that. Okay, the comment, Katie, let me know if that makes sense. The comment that I wanted to make here before we look at an algebra solution is if any of you guys have quant scores in the 40s, okay, let me disable the Blackboard permission. All right, please no doodling, but now you can't doodle anymore, ha ha ha. Okay, so if you have a quant score that is already in the 40s, then, I mean, I will make you a promise. And that is that studying more mathematics is really just kind of a waste of your time. And that includes studying more algebra solutions to things. and studying more like principles of math. I mean, that will not improve your score if you are already in the 40s. If you are already in the 40s, then learning extra strategies like this one is absolutely the only thing that will improve your quant score. A reliable further improvement. It's the only thing. I mean, if you are in the 40s in quant, then you know more than enough mathematics. In fact, probably if your quant score is anywhere from 35 on up, then you know all of the math that you really need to know to take this exam. And it's this kind of thing that is the point. So meaning we'll look at the algebra solution here just for completeness, but especially the person who asked the question about the algebra solution. The best response I can give is if you have a quant score of 40 or higher already, then you shouldn't even care what the algebra solution is. Like this is the thing. This is where you're going to get extra mileage from. So, because algebra is algebra, you're going to be able to do it or you're not. But if you're not doing things like this, that's a thing. Okay. Then it looks like it made some of your text into an icon. Sam, I mean, you could probably post that in the. Well, you should go read the forum under like general folder because there's a lot of people asking that question, and sometimes it has to do with the way that you study. It might just be a test anxiety thing or whatever, but if you have like memorized a lot of the materials, then yeah, your practice scores are going to be artificially high. So, but there's a lot of forum threads about that. You should search and just do some reading and see what Stacy has to say about that. Okay, so here is, let's look at a general approach to this. But remember, what you should get out of this is the, oh wow, I should have picked numbers if I didn't pick numbers. All right, here's the problem. So I mean, there's a couple of ways that you can approach this. I mean, the point is you do have to visualize. I mean, you have some sort of cube where if you're going to make a drawing, then you do have to make a drawing that is a thing. So you have to, I mean, n is a random number of things, but you do have to draw like some sort of finite number of things happening. So if let's just draw it so that it's like 4, so that we're not drawing straight lines on the Luminate all day. Again, n does not have to be 4. In fact, in our other example, we picked n to be 2. But you have to make a picture of something that is a picture of something. So let's just draw it with 4 by 4. Okay, so the deal here is that there are a couple of ways you can do it, but you just need to express everything in terms of n in a way that is a thing. So okay, so that's a not horrible drawing. It's not super beautiful, but it gets the job done, I guess. So, okay, so one way to do this, I mean, remember that this is not 4. I mean, it's 4 if you pick numbers, but if you're doing a general approach to this. So this is n, number of cubes. And we don't care how big they are because it's a count problem. It's not a measurement problem, so we don't care what the length is. Let's talk about how we might divide this up. See, because the problem is, I mean, you might think it's just 6n squared, but you might be like, oh, look, n squared, n squared, n squared, and then you have 6 faces. So A is tempting, but does anybody see what's wrong with A? Chat box. Where's the problem with A? Yeah, you double count and triple count a lot of cubes. Like if anything is on an edge, which most of them really are, then you're going to be double counting those. And in fact, the ones on the corners, you're going to be counting 3 times. So there's no second, I don't understand, William, no second variable. I mean, there's only one variable anywhere in this problem. So let's figure out a way that we can break this up. Maybe you can explain that further. All right, so we can, but we can get 2 n squareds at least. I mean, we can get, you know, those, that's n squared. Like that top row of cubes, those are all painted. And then you can also do the symmetrical group that's on the bottom. So those are 2 groups that are n by n. So that is, the purple ones are 2 times n squared. There's going to be an exponent there in a second. There's your exponent. Okay. Then, I mean, if you have this visualized, I mean, I would draw this on the paper because you would have to have a truly exceptional mind's eye kind of thing to be able to mentalize this. And even if you could, you would still be, there's no real reason to do that. So another way you could do this now is to take these groups. So you've got that group, and then you've also got a group of those on the other side. So those are n times what? William, yeah, but you don't necessarily know that there has to be a second term. I mean, that's not obvious. So, I mean, sometimes these expressions reduce. It's not 2, Katie, because remember, this is not actually 4. This is supposed to be n. I mean, I had to draw something that was a thing, but n could be 100 cubes. It doesn't have to be 4, so this does not have to be 2. It's n, okay, it's n in one of these directions, right? It's n in that direction, the green thing is. But how many cubes is this? It's not half n. I mean, imagine if n was 100 cubes. Then how many would this be? It would be, yeah, Ting's got the whole expression there. But this is n cubes, and this is all of the cubes here except for the very top and the very bottom one. So it's not half n. It's n minus 2. It's just n minus the top one and the bottom one. So, I mean, again, if you need to draw more than 4 faces on this to realize these things, then you should draw more than 4. So the green cubes, the green arrangements have n times n minus 2, and there are 2 of them. So n minus 2. And then you have these, I mean, I guess we can color them blue. You have these groups that are in the front and the back of the cube. And those are n minus 2 on both sides. And you have, there's also a blue group in the rear of the cube. That's the same sort of thing. So blue including the one on the back side is, including the ones on the back side, is going to be n 2 times, again, because there's 2 groups, 2 times n minus 2 squared. So, I mean, okay, you guys can do routine algebra as much as anybody else can, so I will just tell you and not waste the time to do the algebra right now. If you multiply these out and then you add them together, you will get this answer. That'll be what you get. So, how about that? I mean, this is not the only way to do it. I mean, you can also do it by I'll just, without drawing it, just so it doesn't take a million years, I'll summarize another way that you could do it. Where nu a is psi, I don't understand that. but that seems like it's giving you answer A, which means that whatever it is, it doesn't work. I mean, the last thing you really want to be doing here, by the way, is introducing another variable that you don't need. I mean, that would be the worst possible thing you could do. Okay, so the other thing you could do is you could realize instead of, if you can do this indirectly, I'll just give a verbal description of it and try to visualize it, because if I have to draw it on the board, it'll take like 15 minutes to draw it. So indirectly, let's think about the cubes that are not painted. What kind of arrangement do those have? Anybody know? Chat box? It is. It's a smaller set of cubes, but you can be a lot more exact than that. You can tell me precisely what sort of arrangement those cubes have. That's closer. No cigar. It's not n-2 squared, although it's very, very related to that. I mean, it's cube, yeah, right? Because you've got, okay. I mean, again, try to visualize this, but you have this like outer shell of things that gets painted. But if you picture the inside core part of the cube, then anything that's in the middle, it's not on the edges. There's n-2 this way, n-2 that way, and n-2 that way. Like if you have a stack that's 4 by 4 by 4, there'll be a 2 by 2 by 2 group in the middle of that stack. If you have a stack that's 8 by 8 by 8, you'll have a 6 by 6 by 6 group in the middle of that. So it'd be a smaller cube, which is n-2 on each side. So that is correct, yeah. So there are n-2 cubes that are not painted. And so if you want the ones that are, you can just, that's not supposed to be a 3. If you just want the ones that are painted, then you just take the ones that are not painted and you subtract them from the total number that you have. So total of n cubed. So you just do n cubed minus n-2 cubed. And again, I'll make you a promise. I don't really want to spend the study hall time doing routine algebra on the blackboard. But if you expand this out and simplify it, I mean, it takes a moment to multiply this expression out. But if you do, then you're good. Finally, does anybody know, like, let's say that I mean, this is probably unlikely, but let's say that you just totally forget how to multiply out n-2 cubed. Let's say that you just do not remember how to do that. Does anybody know what you could still do at this point, and you could totally still solve the problem? Or let's say you're just lazy and you don't even feel like, yeah, you could still plug numbers, right? You could just plug a number into this, and then you get a number out. Like if I plug in, I don't know, 5, then I get 125 minus 27, which is 98 cubes. And then if I plug 5 into these choices, that one will be 98, and these ones won't. So you can always still plug in numbers. It's always a thing. So there you go. So we got 3 different solutions to this. Those are certainly not the only 3, but those are 3 is the point. So we have, but most importantly, make sure that this method of just picking a number is on your radar. Because, I mean, look how, I mean, I know that easy is a dangerous word here, but look how easy this method is compared to those other ones. I mean, compared to having to carefully enumerate things in a picture, or compared to having to actually visualize the interior of this stack of cubes. I mean, this is a cakewalk compared to those things. So if you don't have things like picking numbers on your radar, then you are at a extremely severe disadvantage compared to people who do. Just make sure you know that that's a thing. Okay. Let's do, if you picked an odd number, it wouldn't be any different, Elias. If you picked an odd number of cubes, it would be precisely the same story. Because this doesn't, remember, you're not dividing anything by 2 in this problem. I mean, you're just subtracting. So if you had 3 cubes on each side, then this would, the green width here would just be 1 cube instead of 2. So if you had a 3 by 3 by 3 arrangement, you might be able to just picture this in your head. But if you had 3 cubes on each side of the arrangement, then you would have exactly 1 cube in the interior of that. Like imagine a Rubik's Cube. You know, I mean, there's stickers on everything on a Rubik's Cube except for the the pivot in the middle that everything goes around. That doesn't have any stickers on it. So, I mean, 3 is actually kind of neat because you can literally, I mean, most people have seen Rubik's Cubes, which will help you visualize this if you have trouble. Okay, let's move on to a new piece of newness. How about that? All right, remember again where you find multiple choice answers. Multiple choice answers are found here. Please do not post them in the chat box. Thank you. And here's a clock. Okay, to be fair, I probably should have allowed more time here because there's a lot of words in this problem. So here's some more time. Okay, remember to pick something. There are, we got 40 people right now and only like 20 answers. So that means that people have to guess things. So please guess things. But remember, this is not a test where non-responses are a thing. Okay, let's see, we've got 22, 30. I mean, there's still 6 or 7 non-responders, but let's go ahead and get this moving. Remember, guys, if you are one of the people who's not answering the problem, I mean, you know what that, there's not too many of you, about 4 out of 39. So, the second alarm was probably about 3.5 minutes. So, I mean, let's talk about that real quick. If you took 3.5 minutes for this problem, is that necessarily a bad thing? Any thoughts on that? Depends. Okay, Frank, depends on what? It's true. It depends on how long you're taking on the other problems, but realistically speaking, I mean, a lot of the other problems are in the future and don't exist yet. So that's kind of a tough thing to judge. Yeah, Rajiv is kind of getting at what we're getting at here. I mean, not inherently is the first point. I mean, most importantly, you know, for the love of all that's good in the world, people, make sure that you do not think that 2 minutes is a limit. If you think 2 minutes is a limit, then you will never finish any long problems. Because, I mean, 2 minutes is not a limit. 2 minutes is an average. I mean, think about what an average is. An average is like an average. That means that longer problems will take more than that much time, and it means shorter problems will take less. So, therefore, I mean, the point is that it's okay. I mean, it's perfectly understandable to take more time here because the problem is very long. And notice this is not an observation about, I'm guessing, difficulty, because people can't guess difficulty. But there's a lot of stuff happening in the problem. On the other hand, the point Rajiv makes is a good point, though, which is if at any point you are stuck, you need to quit. That's the point. I mean, if you spent 3 minutes and you were actually doing productive work for 3 minutes, which is unlikely but not impossible, especially if you took a long time to read the problem, then fine. But if you were ever at any point just kind of like pushing variables around at random, or just doing anything for no apparent purpose, then you should quit. And remember what quit means. I mean, quit doesn't mean you have to leave the problem right now. It means if you can think of something else to try, then try it. And honestly, if you can't, then just guess and move on, which is not fun for anybody, but if you don't do it, then you don't do it. So, all right. Does anybody know a way to do this problem? Because I mean, the thing is that, you know, as far as this time limit goes, I mean, guessing, I don't really place a high priority on teaching guessing here, because especially because that's sort of at odds with, it's kind of at odds with the goal of today, which is to broaden your, you know, flexibility of problem-solving methods. I mean, so we're like, specifically the theme of today is things that are not guessing methods, like plugging in on the cube problem. You know, things that, so we specifically are not thinking about guessing today, is the point. I mean, that has its value, that has its place, but not here. Yeah, so Sai is getting at this here, right? So it's very closely related to the method of picking your own values, but this time it's just picking, sorry, wrong graphic. It's picking the answer choice and just trying it out. So you can kind of do a combination of those two methods here. So you can do a non-algebra method by first you can pick your own number. I mean, let's just pick your own n. Let's say 100. Here's a stupid question, but why are we just picking n? Why are we not picking n and picking p? I mean, at least why are we not plugging a random number in for p, is the point. Yeah, because p, there's a right answer for p, though. So, exactly. If I make up that p is like, I don't know, 25%, then I'm just wrong. Just all kinds of wrong. There's no right about that at all. So then try the answer choices. So just make sure you know you can't make up a value for p, because p has a right answer in the answer choices. So, but you work backward from the answer choices. In other words, instead of starting with the problem and ending with an answer choice, you start with an answer choice. You just do whatever you can do with the information in the problem. And then if everything is consistent with everything else, then you're good. And unlike the making up your own values, here you do not have to keep trying choices. Because it is, if you make up a value, then it's possible to get a coincidence. But if you use their answer choices, then 4 of them will just be wrong and 1 of them will be right. So, all right, let's say n is 100. So then 1997 is $100. I wish I only paid $100 a year for auto insurance. That would be pretty nice. Okay. The other thing here is what is the most important thing to keep in mind when you pick an answer choice to start with? What do you guys think? Like when you're deciding which answer choice to try first, what do you think? Yeah, I like what William is saying. I mean, it's not, you cannot memorize a choice to start with. I mean, there are problems where C is a good place to start, and there are problems where C is a bad place to start. Same thing with B or D. But William's got the point here. The point is that you want to pick a choice that is easy to work with. Because that's really what it is. You don't want to waste, you don't want to be inefficient here. So like, I mean, 33 1/3 and 36 44% are not that great. So meaning I don't really want to work with those if I don't have to work with those. So let's just start with 50%. Because I mean 50% at least is a very easy number. So let's try that. Yeah, fine, but we're not doing algebra right now. Okay. So let's just try E, 50%. Then that means the 9098 premium was $150. So then 1/6 of this is, that's 6 times, what, 25. So 1/6 of this is $25. So in 1999, you get 125 bucks. And then 1/6 of this value, it's not $125 again, is the point. It's some horrible, ugly thing, but it's between $20 and $21. Because it's 120 would be 20, and so you have, and 126 would give you 21. So if you subtract that, you get 2,000 is, somewhere between 104 and 105. So what do we notice about that? I mean, it's too big. But does it give us any clues? Yeah, it's really close, right? It's only off by like $4. So, I mean, this gives us a pretty good sense of what we're looking for. So we do need to pick a lower number, but I mean, that's sort of trivial here because all of the numbers are lower. So, but the point is this is really, really close to 100. This is not far off. So you don't really want to get drastically far away from 50 here because 50 is close. So then try the next closest answer. So if it's 44%, I mean, that's not super great. But 1997, $100. So then you add 44% of that, which is $144. So 1/6 of $144 is $24. Take that away. It's $120. And look at that, 1/6 of this is $20. So, boom, we win. And again, notice in this method, you don't have to keep trying choices because these are their percentages. Like these will either be straight up correct or straight up incorrect. Like there's no coincidence, weirdness that can happen here. So again, no need to even do algebra. There is algebra that can be done, but no need to do it. And I mean, the other thing to notice is that you will still have plenty of time. Like you don't have to decide to do this right out of the gate. Like that's the other problem that people have, is they think that you have to like, oh, I need to know right away that I'm supposed to do this. Well, no. I mean, this doesn't take very long. So even if you try algebra here and get stuck, As long as you are not sitting there staring endlessly at the problem, you will have plenty of time to turn around and try a method like this one. So as long as you are not, again, sitting there staring or just doing random work with no goal. If you are not doing those two things, then you will have all the time you need to try other stuff, I promise you. So working backwards, it's your friend. And again, if you are at 40 or above in quant, then these are really the only things you should be worried about learning. I mean, you don't need to learn any more mathematics if you're ringing up 40s in the quant. So Rajiv, it doesn't matter. There's no reason for a student to ever think about that. It doesn't help you in any way. So there's just a problem and there are methods, and thinking about difficulty is just a distraction. Okay, if you want to do algebra here, you can do that. Let's say, so P times, so that's the problem, is that P is a percentage, right? So you have, you can't just multiply P by fractions because those are not equivalent quantities. But let's take that over here and see what happens. So if you, I mean, I'll just sketch out, I don't want to spend a million years talking about algebra, so I'll just sketch out a couple of solutions for you. One solution that uses two variables is let X be the 1998 premium. The one that, because, I mean, it's nice to have a variable there because that's the thing that you actually take fractions of. Whereas P is, you don't take fractions of the 97 value. So you have, the point here is in 1998, it's $N. And then in 1999, it's 5/6 of that. So if you're not sure what the 5/6 is, I mean, if you take away 1/6 of something, then you have 5/6 of it left, is the point. And so then 2000 premium is that times another 5/6. So it's 5/6 times that. So that's 25N over 36. That's actually X. These are all supposed to be X. X, 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 X. So, and then the point is that this has to equal N, is the point. So then if we can reverse that fraction, you multiply by the reciprocal, and you get this. That's, I am just dyslexic today. That's supposed to be an X. That's supposed to be an N. Notice what this tells us, right? 36/25. You can multiply that by 4 on the top and the bottom, because then you get your denominator of 100. So that means 144% of N, which means that it's 44% more than N. So you can do that, and that's a solution. It's not the only one, but it's a sketch of one. If you use one variable, I'll just show you how the equation is set up, and then you're pretty much good from there if you know how to do the algebra. So if you want one variable here, yeah, Peter wrote in the window how to do the percentage increase. So you put this on a flashcard. This is the kind of thing you should know by heart. To increase a quantity by P%, that's multiplication by 1 plus the fraction P over 100. So that's the first step that happens. So then let's just make that a graphic that I can keep loading. Okay, so the point here is that if you start with N dollars in 1997, that's N dollars. And then in 1998, you have N dollars times that thing. And then you do the 5/6 to that. So in 1999, you're going to have the same quantity times 5/6. So that whole thingamabobber times 5/6. And then finally in 2000, you're going to have the same sort of story, except you multiply by another 5/6, which means you get a 25/36 in the back of that. So same expression, except you've got another 5/6, which means 25 here and 36 here. So then you can, I mean, this is an equation. This is not the most beautiful equation in the world, but it's an equation and you can solve it. So if you solve this, then, because this equals n by definition, so you can cancel out the n's, and that gives you a 1 on the right-hand side. And then take my word for it, work it out at home or whatever. If you do this, you'll get 44 for P. I think this is what Cy had up there earlier in the chat box. So, good times. But again, the point is not just this. I mean, at the risk of sounding like a broken record, the point is that you should be just as able to do this as you are to do the algebra. The other really important point is that you should not think of this as a backup method. Like it's not really a backup. I think I called them that a couple of times, but they're not really backups. They're methods that are just every bit as good as textbook methods. So you should think of algebra as priority number 1, and you should think of this kind of method as priority also number 1. It's not priority 2. Because if you think of it as priority 2, you just won't use it, is the problem. Okay, if we really hustle, I think we can do another problem. So let's see if we can make that happen. What do you guys think of KT's question there? How do I know when plugging numbers will not work? Okay, those are insights that are decent insights. That's not really where I'm going with this. It is a good question, so we're addressing it. Yeah, the things you guys are writing are not wrong, but I mean they're not totally right either. I mean, it depends on what you mean by specific numbers, because like sometimes you can still pick numbers if the answer choices are numbers. It all depends on the problem. But none of you are going where I'm going with this, so let me just go there. The only good response to this, really, in my book, is just try it. You know, I mean, as long as you are not blatantly contradicting the problem, then you will be fine, right? If you, I just realized that there's a problem up there, so let's black out that problem for now. Okay, I mean, as long as you are not blatantly contradicting the problem, then you should just do things and see if they work, right? So like if you, in this problem that with the percentages, I mean, you can't make up P here, and that should be pretty clear. Because when you look through this problem, there are correct answers for P, and there are 4 incorrect answers for P. So you know that you can't make this up, and I think that's where the people in the chat box are going with this. But apart from that, if you're not sure whether it will work, the only reasonable thing for you to do is just give it a shot. Just try it and see if you can get it to work. Because remember, the whole point with time management is as long as you are not, I mean, if you quit other methods as soon as you are stuck, I promise you, you will have plenty of time to try whatever method at whatever time. Like, this is only false if you are like so slow that it takes you like 5 minutes to do a log division problem, which I don't really think is going to be true. So other than that, if anybody here has difficulty with time management, that is always, always, always a function of just sitting there staring at things, or of like pushing variables around with no reason behind it. If you just don't do those things, you'll be fine. So it's the best answer I've got. Just do it. See if it works. Okay. So try that. It's not a super long problem, which means it shouldn't take that long. Maybe about 2 minutes or so. Okay, on this problem I will give you a fair warning, and the fair warning is I wrote this problem for the MGMAT challenge problem archive, so this is not going to be a super, let's just say this will not be super easy. But yeah, if you don't know what the challenge problem archive is, you can, it's in your student center. It's kind of, the problems in there are super obnoxious, kind of nerd fun. Like, they're way harder than anything you'll see on the test, but they're still a good place to develop these skills. I mean, because you can still throw the same kinds of approaches at those that you would at normal problems. But go ahead and guess. I mean, this problem is, again, there's like 12 of you who left this blank. So let's get some guesses in there. I mean, no shame in making a random guess here. This is probably harder than anything that GMAT will ever give you. So so we're kind of all over the place. I mean, the answer that most people are giving here is not the correct answer. This is not C. So looks like people are kind of just guessing at this point. So that's cool. That means there's some learning to do. So one thing that you want to be able to do, and you want to make sure that you do this carefully. I mean, make sure you don't mess up key steps like this. So we have, I don't know if that's supposed to be pronounced Marchikeen or something like that, but Marchikeen or whatever that is. I mean, careful because this is backwards. I mean, the problem says that the ratio of A to B is actually 2 times the ratio of B to C, not half of it. So the way that, if you have that, you're kind of, that's not an auspicious beginning to get that statement reversed. So here's what this should be. It should be this. A over B is 2B over C. That's what you want. You take whatever time you need to take to do that, because again, if you screw up the initial interpretation of the statements, then you're basically dead. I mean, the rest of the problem is not going to work by pure magical coincidence. So make sure that you take whatever time you have to take to make that work. So, okay. Let's try working backward from the choices. So, I mean, let's start with choice C just for fun, because that's no good reason. They're all random choices. You could literally try these in any order at all, because like this is a matter of things being integers or not integers, so there's no such thing as too big or too small in this problem. So literally you can try these choices in any order at all. It's just kind of random. So don't deliberate too much on which one to try first. Just pick one almost at random and try it. So since most of you guys seem to like choice C on this problem, let's try choice C. So A is 20% less than 28% less than C. What does that mean? How do you write that with fractions? Chat box. How do you write that with fractions? Or what percent of C is A? If it's 28% less than all of it, then it's 72% of C. So, or A is 72C over 100. Which you can reduce that to, you can take a 4 out. So that's 18C over 25. So then let's substitute that into that expression up there, because that's the only thing that's literally the only thing we can do is substitute and just see if this is a thing. So if we have A over B, so that's 18C over 25. Divided by B is 2B over C. I mean, there's a number of ways that you can handle this thing, but one thing you can do right now is you can take a 2 out of the top and of both fractions. So you can strike the 18 and make it a 9, and you can strike the 2. So that is 9C over 25 and 1B. So if you cross multiply this, you get 9/25 C squared is B squared. Can you get integers to do that? Well, sure you can, right? I mean, you can let C be 5, and then B would be C has to be some multiple of 5. You can take a square root of that, so it's 3C over 5 is B. So if you have that, then you can start looking to see if you can get integers. But these are all integers. So you have that's the point, right? Like you have the ratio of C to B now. So the ratio of, you can divide out B to C if you divide both sides by C. And then the ratio of A to B is just twice as much as that. So that's this. I mean, you can do this. This is doable with whole numbers. I mean, you don't have to really worry about what those numbers exactly are. But if those are all integer ratios, you can definitely get that to work. Like if you give me any 2 integer ratios of A to B and B to C, then because you just take the least common denominator of all of those, and then you can get it to work. So that is, we're looking for cannot be true. So that's not gonna fly. I mean, this looks like a time investment, but the thing is that once you've done this once, like that's the thing that people are not thinking about. Like people think that if it takes n amount of time to do this once, then it will take 5n amount of time and you have to do it 5 times. Which it totally was, right? It's the same process every single time. So once you get this figured out, it's actually pretty fast. So anyway, we need to keep an eye on the clock here, so let's just move to what is the correct answer and let's try it. So you can try these randomly in any order that you would want to. You get to eventually around the point where you try A, and C is 60% less than A. That means C is 84% of A. So C is, you just follow the steps on the right. So it's 84 over 100 A. Which you just reduce to 21 5. You might see where that is headed. It's 21 is there. If not, you keep going. So plugging into the exponential and A is 21 over 5. That might break it up. Okay. How's that? Okay. This is not sustainable for more than a couple of minutes, but that's all we have anyway, so good. That's 21A over 25, that's A, and then that's 2B up there, and that's B. So if you multiply that out, you get 21A squared over 25. And then on that side, and then you get 2B squared. And so over here, you can divide out that 2. So 21 over 50. A squared is B squared. So the problem is that, remember that both of these numbers are ostensibly supposed to be integers. And if you take the square root, it doesn't wind up being a nice ratio of integers like this does. Like B here is just 3/5 of C. I mean, like this means you can't pick any C in the world, but you know that there will be a C, a B, and an A that do this. And as long as you can have something, then you're good. So, but here, if you take a square root of that, that's not going to happen, right? It's going to be like rad 21 over rad 50 times A is B. I mean, there's no way that this is possible with integers. Peter, maybe I'm not communicating effectively, but I tried to, I mean, I've said several times that there's no clue at all which choice will, because there's no too big, there's no too small, there's no way of telling what is going to happen with these. So you're literally just trying them completely at random. But the more important answer to that point is, to Peter's question here, the much more important answer to this question in general is, because C was random too. Like I only started with C because like half the crowd here picked C. That was a random choice. I mean, but the general response is, if you don't know the answer to this right away, then just guess a choice. I mean, that's the point, right? I mean, that's really where the rubber hits the road, is whether you just do stuff when the pressure is on. I mean, if you don't immediately within like 3 seconds or something see, and you know, okay, I need to go in this direction or something, then don't worry about it. Just throw in a choice. As you can see, it doesn't, like, it takes a little while to figure this out the first time, but then plugging in more numbers is very fast because the process is the same. So there's no difference. Hope that helps. Okay, this problem is going to be in the challenge archive at some point in the near future. So I mean, there are other ways without working backwards to solve it. I mean, you can do it with all algebra if you let this ratio be R, and then this ratio would be 2R. You can do that. We have to close up shop here, but look for this in the challenge problem archive in the near future. And Maria, not really. You'll have to wait for it to show up in the challenge problem archive. But that'll be a nice opportunity for you to sit and play with it for a little bit if you want to. I mean, this is already a solution. I mean, we're done. We solved it, right? Because this is impossible with integers. So if you're asking what's the answer to the problem, the answer is the first choice. Because you can't have integers that are rad 21 over rad 50 times another integer. But other than that, I mean, for the other solutions with algebra and whatnot, then that'll be in the challenge archive in a second. Okay, we are sort of on a tight schedule here, so I'm going to cut it in about a minute. If you have any, Maria, yes, that's what I was saying. It will be in the challenge archive, and there will be additional solution methods at that time. But yeah. Okay, so let's quit it. Again, in closing, these are the good guys. Them and the Florida Gators. Gators aren't playing today, so these are today's good guys. Other than that, if you have any administrative notes, feel free to, Gators, feel free to, I mean, if you have any super fast, like, business questions, you can ask them right now. Otherwise, submissions go on the webpage. And I will see you all in 2 weeks. So, Peter, there's no way of telling if you're in a trajectory that the correct answer will be picked last. That's the whole point. You're not going to be able to tell. If you could tell, then you would just go to those answers and pick them first. So that question is like a non-question. That's not a real situation. All right, guys, we're going to wrap this up. So, yeah, I'm going to kill the recording. And good night and good luck.